Okay, I think we can start, no? So yesterday we discussed about matplotlib, and today we are going to discuss about X-array, because so far we discussed about like how to discuss plot line series or scatter plot. Now you don't need to know about like how to plot a scatter, like not the spatial plot. To go with the spatial plot, we need to load the data. So typically our data is in HDF file format or GIF file format, or commonly format is like NetCDF. To read NetCDF, we have a library called Xarray. So Xarray is there to read like multi-dimension data. So today we will discuss about Xarray. So you have to download those two files with the data file. One is like NetCDF data file, and other one is Xarray. Our documentation that we are going to discuss today, the code. So you can load your environment and turn on the Jupyter notebook. Yeah, we will discuss about NetCDF, how to read the NetCDF file, and we need to know about like CF conventions, climate and forecast. Yeah, both. Both files should be in the same directory. Do we need to discuss about the exercise yesterday? Like methodically, I asked about one example. Like at the end, I asked you guys to like read the like do some exercises in here. At the first one is plot these two variables on the same figure using plot, and one in scatter, and other one is color change or something. So for this one, how we can do this? First, you need to run all of these scripts, because now you are going to run your script again in a new session. So you have to run all of these cells before we go there. Okay, output of all cells. So let me load data and like go towards the in. So now here what I am asking is plot two list variables on the same figure using plot, and one in scatter and another one is normal plot, and change the color, marker, line style and legend of the figure. So how many variables are there in our data frame? So how I can check my data frame? I can click on this debugging icon and go to the variables and see the current variable names that I have assigned. So I have data frame. If I go here, which data frame I use, I can see I use df var. So if I need to plot the data, I can access that variable. So from let imagine like if I type df1, let me type df1, what are the variables that we have? Df1. Our variable is data frame. So in our data frame, what are the columns that we have? I can directly type I can directly type df dot column. So it should give me the all the column names. So what are the variables that we have? Air temperature, therefore in degrees, SLP, wind direction, wind speed. These variables are there. So you can select two of these variables and create the plot. So for this example, I will select wind speed and sea level pressure. So how we can select these two variables? We discussed how to select the entire column last time. So here I am assigning variable name separately. So my first variable name will be wind speed, second variable name will be sea level pressure. Then I am calling for okay from df, drop, axis index and subset. That means I am asking to do a subset. Now what will happen? So from this entire data frame, if I see the df, so my entire data frame is like this. Now what I am asking from entire data frame, I only need a subset. That means I only need the selected two columns with the rest of the values. If I execute this one at the end, what will happen? It should give me those two column values with the data frame. I am asking variable 1 and variable 2. So here if I see df1, I have sea level pressure in here and then wind speed in millisecond. And then I am calling for that data frame and asking df1 date time to be x-axis and then y data will be df1 variable name 1. That means in here I mentioned wind speed. So x1 y1 data will be wind speed and the other one will be mean sea level pressure. So for this one you can select any of your variable. It's up to you. And then same thing. When we discuss the matplotlib yesterday, we discussed you need to first you need to create a figure. For the figure, the size will be 10" by 8". This one you need to be tactic. Like if you need your graphs to be something like this, if you are going to divide your what we call sketchboard or something into like this, then height should be small and it should be bigger. If you are going to, if you are planning to divide this something like this, then your height should be more than your width. So that's the main point. If you mention something in here, you need to understand, okay, if I am planning to plot something like this, then you have to specify the size in here accordingly. First one will be the height, the width, the second one will be the height. So then what I am asking, plot. I said like in this exercise, I just ask you guys to create two plots using one from plot, other one is from scatter. So first one will be plot. I will do the plotting for x data and y data. That means x data is my date and time, y data 2 is my SLP, sea level pressure values. And then for the scatter plot, I am going to plot x data, that means date and time, y data mean wind speed. So if I execute this one, it should be like the color will be red for the plot and the color of the scatter will be blue. Then I am asking, okay, plot show. Now in the same graph, this one is in the same graph, not in two different graphs. So if I need to do this one separately, what I can do? So now I am doing this one, y data 2 dot mean, what will happen? What does this one do? Y data 2 dot mean. You can check. It is getting the mean value of y2 data, that means sea level pressure, the mean value of the sea level pressure. And then I am asking y data 2 minus y data 2 mean. Now what I am going to do? So if we subtract the mean value of all the values, what will happen at the? Then I am creating an array, subtract all of the values in y2 data with the mean value. So at the end, you will end up with positive and negative values. And then I am asking, okay, then y1 data NP0 df1 variable 1 is wind speed, where df variable 1, that means wind speed is greater than 0 and none. If those values are there, just keep them. So if I execute this one, what will happen? So I will have two different data size datas. I will have y2 data rescaled. So this data is rescaled. So because in here y2 is in red color. So y2 values are over here in 10,000 range because those are pressure values. We know pressure is typically ranging between 900 and 1000 if we compare about like sea level. So that's why we have a graph like this. So I need to take this graph down here so I can show the variation much more closely because here I am focusing on wind speed. We know wind speed is not going around like 1000 or 800. Wind speed is typically around like 20, 30 or 40, maximum 40 or something. It will not go beyond that, like 100 or 200, it will be a tornado or something. But it's not going to reach 1000 or 800. So now I need to plot this graph around here. That's why I am doing this calculation. So I am subtracting all the pressure values with the mean value. Then I will end up with smaller values. And then I am filtering by one data as well. If the wind speed is 0, only keep the values which are greater than 0. So I am removing all the wind speeds with 0. And then I am again calling for the plot. This time I am calling for x data and y2 data rescale. That means this rescaled data. So now all the pressure values should be subtracted from the mean value and then I should end up. Just imagine if the value is 10,015 and the mean value is 980 or something, I ended up with the smaller value. So now if I am going to plot that data in the red color and for the scattered data I am using y1 data with no zeros. So that means there will be no zero values and I am going to, since it is a scatter, I am going to assign the color blue and the size of the mark as 10 and this time mark as plus marks, not like dot marks or something. This one, it will be, this time it will be plus. So if I execute this one, I should have a plot, something like this. Now you see the red color, that means the pressure values. Why we see pressure values like this? Because we did the calculation. We did the subtraction of this one. We are subtracting all the values with the mean value. So at the end, we will have a zero line and we will have ended up with like some positive values and some negative value. So the blue color one is the wind speed. So here you can see wind speed is not passing around 15 or something. But mean sea level pressure, you can see it is much higher. And then for the second exercise, what I asked. So if you need to plot this one in two different plots, you know what's the command. We need to create two subplots and then put one in another, one in one plot. We need, when we are calling for this one, we need to call for AX1 and AX2. So we can separate these two graphs. So the next one which I ask is we have already looked the weather data in hourly basis. Can we compare two variables on monthly basis? So how we can do, like right now we have daily data, because if you check on here, not daily, actually it is hourly. So we can group this one into daily. So now how we can group this one into monthly? Yeah, monthly. How we can like convert this data into monthly basis, because right now we have hourly data. Now how we can compare two variables on monthly basis? Because right now if we see the plot in the x-axis, we have days values, not the months, because we have days, because each of these single point represent one day. Now how, what if we need to like go with monthly basis? We need to use group by command, because we have monthly column, so we can group according to months, because we have months like separate column name months. Last time when I discussed about numpy, we say we can use group by command to group any variable. Last time we group according to the stations when we are discussing that practical example. This time we are going to group by using months. So how we can do something like that? So for that thing also you can use the same command. I say like when we are calling for the group by command, df variable, that means our data frame name, and then I am calling group by. So now what I am going to group by according to data frame, then month column. Because if I execute this command only, what will happen? If I execute this command only, what will happen? dfr.month, what will happen? It will give me the month column, no? So now I am saying, okay, all the data according to the month and get the mean value. So what will happen? For each month, it will calculate the mean value of all the variables. So the new data will be saved into monthly data. Now the same way, if you have like hourly data and now you need to convert like it into year wise, how you can do it like according to the year wise? Same thing, you have to go with year. If you have a year column in here, you can go with year. But in our data, we have only have the values for 2019, so we cannot go something like that. So at the end, we should be ended up. If we execute this monthly one, we should ended up with 12 rows. So here, how many rows we have? We have 8,596 rows. But after we execute this command, we should be ended up with 12 rows. So now if I execute this one, I should end up with 12 rows. Now I can view the month data. So I can type month data and view the data frame. So now you can see I only have 12 rows. That means all of this data is converted into monthly value. Now I have monthly air temperature, dew point, sea level pressure, wind direction in decrease and wind speed, and those all the variables in the mean format. So it will automatically calculate the mean for me. And then now I am saying the same way. Now you can directly access. Now from the monthly data, I am selecting air temperature. And then from the monthly data, I am selecting the dew point temperature. And then I am creating the NP range from 12. That means for the x-axis, I need to create values from 0 to 12. So now if I execute this one, I have 3 data set. Now I can call for the plots. So months, I can say calendar. From calendar, month attribute 1 to 12. So what I am doing in here is like I am creating variable name like new variable month. I say we imported calendar. It's a by default library in Python. So if we call for calendar variable, there's an inbuilt command monthly abbreviation. So what will happen? It will create. So you can view the docstring of this function. How to see the docstring? So if you see the docstring, you can understand what it is doing. It is creating monthly short code or the abbreviations of each month, and it is saving into a variable name month. So now we have monthly name as January, February till December. And then now we are going to plot. For the X data, we are using the months, and then for the Y data, we are using Y1 data air temperature, and then Y2 data dew point temperature. And then these all the things are plotting formats that we discussed previously. So if I execute this one now, I will end up with air temperature and dew point for months. So now you can see the month names in the x-axis, and in y-axis you can see the temperature values. So in here you will see temperature is increasing. Typically, it should increase around July to August. And then next exercise. So that's how you can convert this one using the group by command. So this is the practical example. Last time we check on the imaginary data. This time we read the CSV file. So from there we are using group by month. But to do this thing, what should need you need to have a separate column named as month. So that means if your data like Excel file or CSV file doesn't have a separate column named month, you cannot do this one. So if you need to do something like that, either you need to split your date into years, months, and then days. If you only have like date type, date, yeah, yeah, hourly data, yeah, yeah. No, directly you can go. Is depend on your file format. So that's why I ask you first. You need to inspect your file before you going ahead with like plotting or anything. First you have to check your file. In yeah, yeah. Then when you are selecting, you need to select all the variables. So if you select only hourly, sometimes it will provide the entire string. Like the date will be like 2024, then then DD days, and then it will give you like hours, then minutes, and then seconds. So you will have a column like this. So typically you should be have a column like this if you go with like hourly or something. And then you need to split this column into months, days, and according to your need. So for that thing, you need to split this one into a separate column name months. But when it comes to X-ray, I will discuss. In X-ray, you don't need this one. But if you are dealing with the data with numpy, you have to split these columns. Or else you have to convert this one into date time format, and then from there it will understand, because now it is in date time format, and then you can do the calculation. So we will discuss about this one in X-ray. So these are like some txt file data. So if you are doing something, you have to do some sort of conversions like this. So the last example is what? Last exercise I ask is, in here I give the hint as a group by using get daily monthly data, and then the last one is what is the diurnal pattern of summer temperature? When does the highest daily temperature occurs in summer? So how we can check this one? What we mean by the diurnal pattern? So now I am asking about the 24 hours, not anything. So x-axis it should be like 24 hours from 0 to 24. So that's why we call like diurnal pattern, like how any variable change within 24 hours. So typically for air temperature, you will see a graph like this. Till like around 1 p.m. or something, we will have the highest temperature. If you plot with the temp, and this one axis will the hours. So we will have highest temperature around 1 p.m. and rest of the curves will be the hour value. Now I am asking you to plot the diurnal pattern. So for this one, how you can access? And I am saying diurnal pattern for summer temperature. So for this thing, how we can do? So for this one, we need to set the index as date time. Now I am setting an index as the date time. So what will happen in my data frame? If I check my data frame, df underscore var, but I will see I don't have an index name, date and time, but I should have a column. Like at the beginning, I say I converted this date time into a date time column. So now I have that date time column. So I need to fix this one as my index, not in a separate column. Now I am fixing it as an index. So after I execute this command, this column will be my index. So I will not have these values in here as the index. And then I am saying for the summer temperature, I am saying df var. Now select all the values ranging between this time period. So now I need all the data from 2019 6 to 1 and then for these months. So how many months it will be there? 6, 7, 8, 3 months will be there. So I need to get all the rows related to these 3 months. Then I am asking, okay, summer temp 2. So I am creating another variable. This time I am accessing this data set. So let me execute this to separate this. So then you will understand. So if I do something like this, what will happen? And at the end I can print summer temp. So now you will see I have the data till 2019 August 31st and the starting date will be 2019 6 June 1 and rest of the data will be saved. Now what I am doing, I am saying, okay, from that data set, group it according to summer temperature, index hours. So you ask something like hours. So this is that example. So if you have hours like that kind of column, just imagine if you have in your data, you have that column. I said you need to convert this one into date time format. So after you convert it into date time format and set it as index, now you can call this one. Now what I am doing, summer temperature dot index mean I am calling for the index. Now in the index I have date time. So now I am saying, okay, dot hours. Now it will understand. If I say hours, it knows, okay, this is date time format. Now this guy was asking me about the hours. So I need to focus on this value. If I say days, what will happen? It will focus on these two values. If I say months, it will focus on months. So this is the another way. So this is another way. If I say minutes, it will understand minutes. If I say seconds, it will understand seconds as well. But in this case, I am saying from index access all the hours and then get mean, because this one I am doing the group by command. First I am grouping it. So if I group, what will happen? For all the days, that means I have 3 months now, 6, 1, 7, 1, 8, 1. For this one will be an entire column. It will group according to the first date, and then for the second date, 6, 2, 7, 2, 8, 2. It will group accordingly. And then likewise, it will group for all the days. And then I am saying, okay, just like get the mean value of this group data. So now it will calculate the mean value of these 3 values and store it in array. So at the end, I should have how many in here I access like hours, no, not days. So this one should be not like this. So it should be like for each day, it is getting the hours. So how many data I will have, like 30 or 31. 30 or 31 data will be there for first hour. That means 0, 0, 0, 0, 0 in 24 hours. For this one, it will get the values for all the days. That means how many days it will be there. For the, we have like how many months for these 3 months. For this data, if we divide by 24 hours, you can get the one data set. Then for first hour, likewise, it will calculate for 24 hours, 23, 0, 0. So it will calculate for all the hours and get the mean value. So now it is calculating the mean. So if I print this data in here and display, you can see now I have 24 values. Why? Because now I access hours. For a day, we only have 24 hours. Now it is converted into 24 values. I have the mean value for 24 hours. So now what I need to do is I need to get the hourly temperature average over the summer. So how I can access? Now I am accessing the variable and saving it as diurnal summer temperature, because I say you need to plot the diurnal summer temperature. So I am accessing the air temperature in degrees and saving it as a separate variable. So if I print diurnal temperature, what should I see? Only one single series. So now we will use this one to do the plotting. So first we create the, now we need to create the x-axis. For the x-axis, I will use index values. I can use directly the index values in here 0, 1, 2, 3, 24. So now I am using that index values as x data, and now I can do the plotting. So my x data will be 24 hours, y data will be my temperature value. So now I am doing the plotting in here, diurnal summer temperature, and then the color will be red, label will be temperatures in C. So in here, if you see, I only have one variable. So then I am saying y label as temperature, font size as 0. How I can do this one with one variable? This time I am only giving one variable. Why? I am passing a series. In series, we already have index values and the values. So it will automatically take the index values as x-axis and the rest of the values as y-axis. So I don't need to pass two variables. Then I am saying, okay, for x tick marks, rename this one with x data. That means it will rename according to the tick marks. And then I am just plotting this one. If I plot this one, I should end up with a graph like this. For the summer temperature, you can see how it is changing. So if it is changing something like this, you can see how the temperature is varying. And then there are some other commands. So this is the main thing that I need to discuss. Then we can discuss about the X-ray. So these are the solution. I will give you the solution for these things in the group. I will send it to in the evening. So now we can discuss about X-ray. You guys can load the folder for the X-ray. So now for the X-ray, for the introduction, I say X-ray, what we call X-ray is, we are using, in this one we will discuss what is X-ray and how does X-ray fit with NumPy and pandas, and then creating a data array and open an XCDF file using X-ray, and then how we can subset. Because in this case, we are discussing about multi-dimension. So far, we discuss only one dimension, no 2D data. We only discuss about one table. Now, we are planning to load the data with like multi-dimension. So, if it is like daily data, then we will have like multiple stack layers stored in a single file. So now we need to cut. That's why in this cube, it is like this cube. So you will have like multiple variables with 3D. This one you can imagine, okay, this one has latitude and this one has longitude. So one slice means a map data. So one grid means the value, actual value of that cell. So we discuss about this spatial resolution thing called. When we are discussing about like in GIS courses, we discuss Landsat has 30-meter resolution and then Sentinel has like 10-meter downscale resolution or something. So that resolution means this one grid is equal to, in real world, it will denote like our entire data set will be something like this. Okay, the entire resolution will be like this. But for the minimum block or minimum cell, this one will be 10 meter by 10 meter when it comes to Landsat. If it is MODIS, sometimes it will be like 250 by 250 or 500 by 500. But then our entire data will be like divided into these kind of cells, and we store the data accordingly in this cell value. So now how we can access this data? So before we go ahead, we need to like know about the structure of the NetCDF files. Before you play with any kind of data, you need to understand the structure. So for that thing, we will load NumPy and X-ray to discuss on how we can do this thing. So in here, so you need to know that we need to have like coordinate names and the values. If it is an HCDF file, we need to have coordinate names and name values. Then we should be able to make some slicing and indexing and much more powerful things. So now we will try to create some X-ray data, then you will understand the structure. So first we will import NumPy and X-ray to create some sample data, and then now what we are creating data, we are adding 825 plus 5, that means it will multiply by this random number and create some sample data. So if I print the data, it will be something like this. So this will be what kind of data? So how many columns are there? 1, 2, 3, 4. 4 columns. And how many rows are there? 1, 2, 3. So how many dimensions are there? 1, 2, 3, 4, 5. So here you can, from here you can see, I am saying at the end, I am saying randomly organize this one to 5 dimensions, that means 5 tables, and then 3 rows and 4 columns. So just I am creating some sample data. Now you can imagine I have. So if you type how to view the dimension of this one. So I discussed about this one previously. Whenever you need to view the dimension, you can type that command. I discussed this thing previously when I am discussing X-ray, not X-ray, pandas. So whenever you need to check the dimension, you can type ND. Then it will give you the dimension. So this one is 3 dimension. So now how I can convert these values into an X-ray data format. So to convert it into X-ray data, so you can call for X-ray. So in here I imported X-ray as XR. So now I am calling XR data array. So whenever you need to convert something into a data array, there's an inbuilt function called data array. It will convert all the values or numpy arrays that you have created into X-array data format. So now if I view this one, now you have something different. So in here, this one is array type data. No, in here you don't have anything. You only have these values. But after you convert in this one into X-array data set, you can see a difference. So what are the difference? You see in here. You see X-array data array, then dimension, and then dim, and then another dimension. So it is mentioning the dimension. This will be the number of tables or number of like separate data sets that you have, and then the columns and then the rows. So when you load the actual data, you will see this one. And then these are the values. And then you have something called coordinates. And then you have something called indexes. And then you have something called attributes. So in numpy array or like pandas, you don't have something like this. But when it comes to X-array, you should be see these variables whenever you load the data. This time we created the sample data to understand how this is going on. Now for this data set, we can pass our own dimension names. Now in here, we have empty dimensions. We don't know what these dimensions mean. So now we need to pass the values for exact like each and every dimension. So in this case, you can imagine, okay, these are like you can divide. If it is a single table, we can divide these tables. Like just imagine we have like five tables, no? So one table contains how many rows? 1, 2, 3, 4. So 4 rows are there. And then we have 4 columns and 3 rows. And now we have the same table. We will have like how many tables? 5 tables will be stacked together. So now you can simply understand this one like how you can say, okay, this one is latitude, this one is longitude, and this one single table represent a time stamp. This one will be like, okay, if it is monthly, you can imagine as this one will be month, first month, and this one will be for second month, and this one will be for third month, and this one likewise you can say, okay, it is monthly. Now we are going to label this each and every individual dimension. So in this case, we can call X array, data array, then data. When we are creating the data, if you view the docstring of like data array function, you will see you can pass data, and then you can pass coordinates, and then you can pass dimensions, and then you can pass names, then you can pass attribute, and even indexes, and then pass path and everything. This time we are going to pass indexes like dimension names. So how we can pass the dimension names? If I view the docstring, over there it should have mentioned how you can pass the dimension. If your data set has some dimensions, how you can pass the dimension names. So you can see on here how to pass the dimension. But in this case, I know how to pass it. So first you need to give your dataset name, and then you have to say okay dimensions. Now I know how many dimensions are there in my Excel like numpy dataset. I had 3 dimensions, so now my numpy dataset is in 3 dimensions. So I know I need to pass 3 values for my dimension. So now I can assign, okay, I know the structure as well. I have 5 separate like same values, that means 5 tables. Then those tables demarcating some time stamp, and then columns will represent latitudes and rows will represent longitude. So now I am going to pass this one. So after passing this one, what will happen? Now if I view the data, now it is saying time, I have 5 time steps, and for latitude levels I have 3 latitude levels, and longitude levels I have 4 longitude levels. What is the purpose of this one? Just imagine when you are going to plot some data, you need to extract one time dimension of one thing. So you can call, okay, time equals 1, give me the first slice. So what will happen? It will slice, it will take only this table and store separately as a data. Even if you need to get like average, you can assign, okay, calculate the average according to the dimension name type. So what will happen? It will do the calculation. It will get each cell value and across all the months and calculate the mean value for that cell. It will keep repeating for all these cells and ended up with one single average grid data. That's why we need dimension names. So in this case, we have dimensions label. Now we have dimension 1 as times, and then dimension 2 as longitudes, and dimension 3 as longitudes. So now we will call for pandas as well, because we can pass some other data, like if we need to create date range or something, we can use pandas. Now I am importing pandas because we discussed about pandas earlier. From panda, there's an inbuilt command date range. So if I call for that command, what will happen? It will create date ranges. So first one will be my starting point, and I am saying period of 5. So if I do something like this, what will happen? It is creating me dates with the time stamp of time period of 5. So if you see the docu string, you can see it is returning a fixed frequency of date type index. So I am specified period as 5, so it should give me 5 interval. That means 2018, January 1st, and then January 2nd, January 3rd, January 4th, January 5th. So when you are opening the data set, you don't need these things. But to understand the data, that's why we are doing this. Now we are creating times because we need to pass. Okay, now we have time dimension, but we need to name these 5 dimensions. Okay, now we have 5 time slices. But the problem is we didn't mention, okay, what does this time 1 means? Right now in the data, I didn't mention, okay, no one knows what does time 1 means. Now I am going to say, okay, time 1 represent the data for this specific date. If it is time 2, is going to represent the second specific date. If it is time 3, it is going to represent the third specific date. So this is how the netcdf file created. This is like we call, at the end I will discuss, this is what we call CF conventions. So just imagine if multiple institute is going to like output their data according to their own format. What will happen? Then all the scientists and everyone around the world, they need to know, okay, these guys are giving us the output in this format. We need to know like how to read this data structure. But right now they are using the same structure when they are processing the data. So everyone will understand this data structure. Now I am creating this time stamp, and now even I am creating longitudes and latitudes. So how many longitudes I have over there in my actual data frame in here? So according to this one, I have 3 latitude levels and 4 longitudes levels. So now I need to name these dimensions, give the values for each dimension. So for that thing, I will also create a line space between 120, 40. We discuss about this one. What is the purpose of line space command? We discuss about line space and arrange. What is the difference between line space and arrange? It will give us 4 equally spaced values between these two ranges. And then I am asking latitudes, give some values in between these two values, 3 values, because I need 3 latitude values and 4 longitude values to name, like give for these latitudes and longitudes. So I will create latitudes and longitudes values as well. Now I can say, okay, this is the way that we can convert numpy array into a X-array data type. Now when creating the data type, first you need to give data. Second value will be, you are passing your dimension names. Now I am passing, no, the coordinates. That means the dimension values. This one you can like Swift, like you can give the dimension name first and then you can give the values. In here I am passing the coordinates for each dimension. That means actual values of each dimension. So now for times it will assign time 1 as first time date, like 2018 January 1st. And then for latitude 1, it will give these values. If I print the lat and lon values, you can see it will pass these latitude and longitudes values. So it should be lat years. So I have 3 values, and even for loans, if I type loans, it will give me 4 values. Now it is going to assign these values. If I execute this command, what will happen at the end? So here I have time, latitude, longitude. But if I scroll down, here you can see I have time, how many values? So if you click here, you can see all the values. I have 1, 2, 3, 4, 5. And then if I view the longitude, I have 1, 2, 3. And then for latitude, I have longitude, I have 4, and latitude, I have 3 values. But previously, I don't have the coordinates values in here. I only label the dimension name. But right now, if you see the dataset name, you can see dimension name is also like highlighted and it displays in bold color. Previously, it doesn't highlighted or show me in a bold color. So now you know why we may like label these things, why we are labeling these things. So whenever we are going to do a calculation, it will be easy for us. Even now we can slice the data according to this date frame. Like just imagine if we have like multiple years in here, we can call from the dimension name, select these years. So it will select the specific data range and slices and give us for our own calculation. So that's why we need to have coordinates. Now the next one is we need to give like attributes. Okay, now we are saying, okay, this entire data is representing, okay, now this set of data, this entire set of data is representing temperature value. But we don't know what is the like unit of that temperature value. How we can assign the unit? Because I say at the beginning, in here, if you see this one cube represent one variable. In netcdf files, we will have like multiple variables. So how we can have that thing? Now we have one single cube, but the problem is we need to label this value. What is the unit and what is the variable name of this specific data? For that thing, we can say, okay, there's one name called attributes. Now we are going to pass attributes. In here you say coordinates. Okay, now we have all the coordinates. And now we need to pass indexes. If you see the indexes, we have time, latitude and longitude. But for the attribute, we don't have anything. Now we are going to pass the attributes. So now we are saying temperature, that means our this X-array data set dot attributes. In like there are some inbuilt attribute types that you can use. Now I am going to assign attribute name units and assign it as Kelvin. So what will happen? So now if I send this data set to someone, he knows all of these values represent temperature in Kelvin. Otherwise, if I didn't mention this one, whether it is Kelvin or Celsius, no one knows. If I pass the data something like this, He doesn't even know whether this is like pressure values or any sort of other value. So I need to label the attributes. I am saying, okay, units in Kelvin and the name as air temperature. Now if I execute this one, what will happen? So here you can see now the attribute, we have two different attribute names. We have unit in Kelvin and standard name in air temperature. So when we load the data, you will understand why we are doing this. When we read some NetCDF file, you will understand. Right now, you don't know why we are doing this thing, but you need to understand we are doing this one for a specific purpose. So now, how we can convert? Now, okay, I have the temperature values. How I can convert these all the values like the same simple uh, mathematical equation. I need to convert these all the values into Celsius. How we can convert these like values in Kelvin to the Celsius? What is the command? Simple calculation, no? How we can convert values in Kelvin to Celsius? So Kelvin to Celsius, we need to subtract the values in Kelvin by 273.15. So now we are calling for our variable name and doing this one. What will happen now? So it convert all the values, not a specific value or specific table. It convert the entire X-array data series like X-array data to the Celsius values. But the problem is here the attribute. Now you can see after doing the calculation, even the attribute names are gone. So you need to understand whenever you do a calculation, attribute names will be go away. If you try to save this NetCDF file and try to send it to someone, it's better to label the attribute as well. So now is the thing is like how we can select this data according to our own need. Just imagine I don't need the entire data set. I don't need this entire data set. I only need one time step. Now the time dimension is also there. I even label the time dimension. So how I can access one table from here? Now we call this one as slicing or selection in this one. For selection, the short command is dot cell. If we call for X-array data dot cell, it will start selecting a dimension or anything that we are going to call. Now here in I am calling temperature dot select. Then the dimension name is time. Why I am typing time in here? Because I have a coordinate name time, and then I am assigning access the time 2018 January 2nd, because from here I know I have 2018 January 2nd. So at the end, what should it give me? It should access the second data set, that means this data set, and print this data set for me, and dimension will be reduced. So now we have time, latitude and longitude, but we are saying select one time frame. Then what will happen? Dimension will be reduced. Now I will end up with 3D data or 2D data. After I execute this command, I will end up with 2D data or 3D data. I will end up with 2D data because why? I am saying I only need one single time step. Then I don't have the rest of the time stamps. I will only end up with one time stamp. So here you can see I only have latitude and longitude. Why? Because I say, okay, from this entire data set, just give me only that time frame. So now it reduced into 2-dimension data set. So even when you are selecting, you can give multiple time stamps. Right now, I only assign one time stamp. That's why it's giving me a single time stamp. Okay, how I can access this time stamp? I can just copy this one. Either I can copy or type. The best thing is like you can view your data set and like you can specify the dates. So I can copy this one and paste it in here. So what will happen? It will give me the specific table for that time dimension. So in our case, it should give me this data set. So if I execute this one, it is giving me that specific table. So you can see from here. And then that's the main thing, you can like use I dot select command to select these selections. And then now I am saying this one is like in selection we have a flexibility like nearest neighboring sample. So now you know in selection If I type OK, something like this, what will happen? 1/7. If I type January 7th, what will happen? In our data, do we have January 7th data? We don't have. In our data frame, we only have the data from January 1st to January 5th. So if I type in here as 7, what will happen? It should give me an error. But there's something called like nearest neighboring thing. We can say, okay, don't select, give me the exact value. If there is a closest value to like this one, it can pass, because you know when it comes to latitude and longitude, we specify specific latitudes and longitudes. No? Now when we going to access a specific latitude and longitude range, that means we are going to click for a specific country. During our first class CDO and grades, we mentioned whenever you have the entire world data, it will stored in this kind of netcdf1 table. If it is a world like global temperature, we are going to access no one like one netcdf file. It should store like it. If it is like entire world is there, it will stored in a grid like this. And for first month temperature, it will stored in time January 1st or something like that variable. But now this one is divided for minus 180 to positive 180, and this one is divided from 90 to minus 90. This one will be like 0. So now if we need to get a specific country, we need to specify these latitudes and longitudes. But when we are specifying over there, they divided these things into not equally like space. It should be like there, it will contain like 0.5 or something for these division lines. But when we are focusing on our country, we should be able to go for the closest value. We don't need the exact value, just give us the nearest value. How we can do that one? So for that, we have an inbuilt command in here, something called nearest. So if you view the docstring of the selection function, you will see we can give the index and then the tolerance, and then we can give the method and some other function. So in here, we can give the method as nearest. So what will happen? If we assign the method as nearest, when we are selecting a data, we assign, okay, method is nearest. What will happen? Nearest mean just give us the closest date for this value in our data set. But to do this thing, we need to give, like I am saying, tolerance. In here, I am assigning tolerance as well. What does tolerance mean? So plus minus 2. So that means if the date I am passing is January 1st, January 7th, I am assigning tolerance as plus minus 2. If minus 2 this one, what should be the value? Plus minus 2. 5. So I am saying 5, and if it is plus 9, so it should be either 5 or either 9, or in between these two values. Actually here tolerance we say like this 2, but we know Python is 0 base. So what will happen? It should go still 4. This one should go still 4. Like we have like actually Python is like 0 base. So if we assign 2, that means 3 days. So other way it should go for 10 days. If it is seeing like any sort of values in between this one, 4, 6, and then 4, 5, 6, 7, and then 8, 9. If this one can see one of these days, give us that value, but it should be closer to 7. So now what will happen? For this one, we are calling to call for this time delta. We have to call for date time. Date time is an inbuilt function like calendar. So we are using calendar when we need something related to monthly names or like calendar format. We are calling for date time. We need something related to date and time both. So if we call like date time, there's an inbuilt function called time delta. It will give us a function name, this one, time delta. So we can assign like array with a specific date range. So now if I execute, what will happen? Last time you saw, it was giving me an error when I type 7. So in here, if